the natural curiosity of scientists have often led them into controversial areas. When the curiosity is backed up by the resources of rich drug companies and is directed toward the secrets of life itself, however, it becomes a potential time bomb. Genetic research is racing ahead without giving society time to establish the parameters of acceptability. Cloning is one of the most controversial aspects of genetic engineering. When an animal is cloned, a twin is created. So far, the process has succeeded only with sheep, mice, cows, and pigs, but several researchers have announced plans to clone human beings. This has already been made illegal in Germany, and is likely to be banned in all Western countries soon. Opponents of human cloning tend to emphasize the risks of children being born with severe defects. But there is also a fear that the technique, once perfected, will be abused in various ways, together with a sense that the creation of life is something sacred and should be left to God. Where the cloning of animals is concerned, however, there is a much less opposition. American scientists managed to clone a gaur, an endangered Asian species of ox, by implanting a gaur embryo into the womb of a cow. Although the baby died 2 days later, its birth was hailed as a major breakthrough, which could benefit not only endangered species such as pandas and tigers, but even species which have already died out. When the last burkado, a mountain goat, died recently, scientists removed some cells in order to produce clones. Some Japanese researchers are even more ambitious. They hope to clone a mammoth using DNA extracted from cells taken from a frozen mammoth's carcass in Siberia or Alaska and inserted into the womb of a living elephant. Another use of genetic engineering is in gene therapy. Many diseases occur because a particular gene is missing or defective. Researchers in Philadelphia have found a way to restore such genes by attaching normal genes to a harmless virus and then infecting the patient. A similar technique has already been used to cure certain kind of blindness in dogs and may easily be adapted to cure humans too. Now that researchers can identify missing or defective genes, it's possible to predict illnesses long before symptoms appear. While this enables people to take preventive action by making appropriate changes to their lifestyles or diet, it also gives insurance companies the chance to identify bad risks. An above-average risk of breast cancer, for example, can be discovered through genetic testing, and some insurance companies now insist that female applicants reveal the results of such tests and raise their fees to cover the increased risk. Once insurance companies demand such information as a matter of course, potential employers will no doubt follow suit, rejecting high-risk job applicants. Of all the applications of genetic engineering, the one which has most outraged the public is the genetic modification of food crops and livestock. In 1996, the first genetically modified tomatoes reached the market. This was followed by potatoes and other crops such as corn, soybeans, and rapeseed, containing genes enabling them to kill insects or to withstand heavy doses of herbicides, and by genetically altered livestock, such as pigs with genes that made them grow bigger and heavier, cows genetically altered to produce more milk, and salmon with growth-accelerating genes. A few people questioned the safety of these products and were assured by industry and government officials that they were absolutely no different from ordinary food products. Questions about their effects on the environment were also brushed aside. By 1999, the U.S. Food and Drug Administration had approved 44 genetically modified crops, including a third of all corn and a half of all soybeans grown in the U.S. In Europe, however, there was growing resentment at the way GM foods had been forced on the public. Consumers began demanding labels that allowed them to distinguish between GM and non-GM products. When the Americans refused to sell them separately, British supermarkets stopped buying their corn and soybeans. Environmentalists wanted proof that modified crops would not harm other species. On the contrary, they heard reports from Cornell University of a drastic decline in the monarch butterfly population related to pollen from GM corn. Then came the announcement that U.S. agribusinesses had developed a terminator gene, which could be inserted into their seeds to ensure that farmers could not follow the traditional practice of taking seeds from their own crops for use the following year. Development agencies were furious. If such seeds were marketed to developing countries, farmers would become totally dependent on American agribusinesses. The resulting bad publicity led to a hasty denial by the producers of any plan to market such seeds. The harmful effects of genetically modified crops on the environment are gradually appearing. The disappearance of benevolent insects, the growth of herbicide-resistant weeds, the contamination of nearby organic farms. Health problems have also surfaced, including a reported increase in allergies and a decrease in the effectiveness of antibiotic drugs. It has seemed likely more serious problems develop in due course. There will be huge lawsuits, and some biotech companies may go bankrupt. However, the system, which has allowed them to gamble with our health and environment, will remain. A system in which priority is given to technological development and profit rather than to safety and social responsibility.